Hi students, glad to have you here today. We'll be doing an activity on experimental probability. But first, let me call on my very reliable assistant, Banoy Bilang. Hi Banoy, so what will we need today? Got that students? Make sure you have your probability simulator app. If you don't have it yet, you can ask your teacher for instructions. First, let's demonstrate how the probability simulator app works. This is the home screen of the app. The Probability Simulator app allows you to simulate different probabilistic experiments. And what do we mean by probabilistic experiments? That's right, Banoy. This means that the tasks you can simulate in the app have uncertain outcomes. Now, to use the app, simply select the task that you want to simulate. So here, you can see the different tasks available. There's quite a number of them, right? So for task 1, let's select roll a die. We can even add more tasks. So for task 2, let's select spin the number wheel. And let's add one more task, draw 2 cards from a standard deck. Once we have made our selection, we can input the amount of trials. This refers to the number of times that the tasks will be repeated by the simulator. For now, let's input 5. Since we're ready, let's tap Simulate Tasks. So in this screen, we see the different outcomes of each trial performed. So through this app, we can simulate these different tasks without needing to do them manually, using an actual die, a number wheel, or a deck of cards. Isn't that convenient? When those 3 experiments are performed, we don't know what their outcomes will be. That's what makes them uncertain. We are not 100% sure about the outcomes. But we can use mathematics to describe the likelihood of the outcomes of the experiments. We can use what we call the experimental probability of an event. So this experimental probability can allow us to understand the likelihood of outcomes by first repeating the experiment many times. When we repeat the experiment many times, we can compute the experimental probability of an event using the formula shown in the screen. We first count the number of outcomes in which the specified event occurs, and we divide this number by the total number of times that the experiment is repeated. Now, let's try an example. Let's just focus on rolling a die, and let's do 10 trials. We will record our outcomes in this table. So as we can see, trial number 1, the outcome is 1. Trial number 2, it's 2. For trial 3, it's 4. Trial 4, it's 6. Trial 5, it's 4 again. Trial 6 is 1, followed by another 1. Trial 8 is 2. Trial 9, the result is 3. And finally, in trial 10, the result is 1. We can now use this table to compute the experimental probability for each outcome. For example, since we got the result 1 4 times out of the 10 trials, its experimental probability is 4 over 10. Similarly, we got 2 times in the 10 trials. So the experimental probability for 2 is 2 over 10. And another example, we didn't get any outcome 5 during our 10 trials. So the experimental probability for 5 is 0 over 10. Now take note that we only performed a few trials, it's only 10, so our experimental probability might not be very accurate yet. Oh, it seems Banoy also has some questions for us. Okay, Banoy's question for us is, how about the experimental probability of the die roll being even? Well, among the 6 possible outcomes, we have 2, 4, and 6 as even outcomes. And as we can see in the table, there are 5 outcomes in which the die roll is even. So the experimental probability that the die roll is even is equal to 5 over 10 or 1/2. Okay, it looks like Banoy has one more question. How about the experimental probability of the die roll being less than 3? Okay, the die rolls that are less than 3 are 1 and 2. We can see that there are 6 outcomes in which the die roll is less than 3. Therefore, the experimental probability that the die roll is less than 3 is 6 over 10 or 3 over 5. Okay, you should practice. This time, focus on the number wheel. Using your Mathplus Probability app, spin the number wheel 15 times and record the outcomes in a table. Then, compute the experimental probability of each possible outcome. Also, compute the experimental probability that the outcome is divisible by 3, that the outcome is greater than 9. In step 5, you have to repeat steps 1 and 2, but this time you have to spin the wheel 25 times. And again, repeat steps 1 and 2, but this time spin the wheel 35 times. Based on steps 5 and 6, what can you observe about the experimental probability of each possible outcome? So that's your practice. Oh, Banoy has something for you. You may use or copy this table to record your outcomes. Thank you, Banoy. Well, that's the end of our activity for today. Banoy, say goodbye.